Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this exercise on multiple integral. Let's start with the first one. So this double integral, we're going to use Fubini's theorem to solve it. So now here's the integral. Six x squared plus 4xy cubed dA. So now according to Fubini's theorem, this integral, we're going to substitute the boundaries, the upper and lower limits of each. Now, if you substitute the boundaries of x here, that means this is the derivative of the area, which is dx dy. When you substitute the boundary of the x, if you substitute the x boundaries, which is 0 and 2 here, that means the one you are going to use here is the x. So that you evaluate the integral with respect to the x using the boundaries of x first before you evaluate the integral of y with respect to the y. So if you put y here and x here, the derivative here will be x and the derivative outside will be y. So it will be the boundaries of y here, the boundaries of x here, then the x dy. So that there will be x and x here, then the outer boundaries is y and y. In the same way, if you put the boundaries of y here you must put the y here. And if here is x, the outer derivative will be x. So it will be, if it's x and y here will be the y and here will be the x. So you must use these two ways. If not, you will not arrive at the correct answer. So any of these methods you use will give you the correct answer. Will give you the same answer, the same correct answer. So let's use dx dy. So if you want to use dx dy to be, that means you put the parameters of x here and you put the parameters of y outside. So let's put y first. This will be 4 and 1. This is the upper limit and this is the lower limit. And this is what? 2 and 0. Then 6x squared plus 4xy cubed. Then this now becomes, this is what is x, so you put the x, then the y outside. So we evaluate the inner integral before the outer integral. So we can put line bars to show this. So now we are going to find the integral, the inner integral first. So the integral of this becomes the integral of, and you know, since the integral is with respect to x, we are going to treat x as the variable and y as the constant. So anywhere we see y, we will treat it as a number. So this becomes 6x squared. If you find the integral is what? Is 6x cubed over 3, which is what? 2x cubed. Then plus, so since we are integrating with respect to x, y will factor out y cubed. This becomes what? The integral of 4x is what? 4x squared over 2, which is 2x squared. So it's 2x squared y cubed. Then we'll put the limits. Which is 0 to 2. Then the y. Then now we'll substitute these two limits into it. 1 to 4. Then this becomes what? 2 cubed plus 2 square y cubed. Then you know that if you substitute 0 here, everything will be 0. So it's minus 0. Then the y. So now 2 times 2 raised to the power of 3 is 16. Integral 1. Then integral, then 16. Then this is what? 2 square times 2, which is 8. This 8y cube dy. So now we are going to now integrate it with respect to y. So this becomes what? 16y plus this 8y cube. It becomes y raised to the power of 4 over 4, which is what? 2y4. Then this is 1 to 4. So if you substitute this becomes 16, 4 plus 2, 4 is power of 4 minus 16, 1 plus 2, 1 is power of 4. So this becomes what? 16 times 4 plus 2, then 4 is the power of 4 minus 16 times 1 plus 2 times 1 raised to the power of 4, which is equal to 558. So the answer of this multiple integral is 558. So now, even though you reverse this integral and put this integral from 2 to 0 here, an integral of 4 to 1, an integral from 4 to 1 here, and you reverse this, you put the y here and the x here, you still get the same answer, according to Fubini's theory. If you try it, you also get the same answer. So this is the final answer of the first one. Let's move to the second one. So here is the second one. Now, let's substitute the variables. Let's substitute the values of x and y. So x is what? It's 0 and 2. And y is 1 and negative 1. In this second one, we're going to use the reverse. Instead of using dx dy, now we're going to use dy dx. But even though you use dx dy, it's still the same. But let me show you the approach of how to use dy dx. So in this one, we're going to substitute x first, then y second. So this is 2 and 0. Then the second one is what? Y is 1 and negative 1. X squared plus 2y. Then this is what? This y, so is what? The y. Then this x. Then this, so this is the x. So we're going to evaluate this integral first. So now, let's do this. This becomes, now, since we are integrating with respect to y, we are going to treat y as the variable and x as a constant. So in this one, unlike this first one, this one we are going to treat x as its constant. So it becomes, this becomes what? X squared y. Because this is just like a constant, so we factor it out. Then the integral of the y is what? It's y. Then plus 2y squared, this becomes 2y squared over 2, which is y squared. Then this negative 1, 1. Then the x. So we're going to substitute the limits. So this becomes what? So anywhere we see y, we're going to put this. So it becomes x squared plus 1 squared minus x squared minus 1 plus minus 1 squared. This bracket is closing here. This one is closing this one. This one is this one. So then there is the x. So this one becomes what? X squared plus 1 minus this minus x squared. So minus times this is what? Is plus x squared. Then this becomes what? Minus 1 squared is 1. So minus times 1 is what? Minus 1. The x. So this becomes what? 2x squared. Because 1 minus 1 is 0. So this becomes 2x squared. The x. Then we'll find the integral of 2x squared. The integral of 2x squared is what? Is 2x cubed over 3. 2x cubed over 3. Then we'll substitute the limits. This becomes what? 2 cubed over 3 minus 0. So 2, so we can use calculator. 2, then 2 cubed over 3, it becomes 16 over 3, which is 5.33. So we can see that this is equal to what? 16 over 3. If you want the answer in decimal form, you can say it's 5.333. So this approximately equals to 5.3. So this is the answer for the second multiple integral. So this is how you use Fubini's theorem to solve multiple integrals, in which case this one is a double integral. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.